Okay, so in this video we're going to be working through the 2017 paper 2, so that's calculator paper. Any questions you have about anything that I do throughout this, just if there's anything that needs clarified, just leave a comment and I will get back to you. So our first question, we have to find the magnitude of v, which is the magnitude of the vector v, which is 18, negative 14 and 3. So when we're finding and working with vectors, the magnitude of a vector is equal to the square root of x squared plus y squared plus z squared. So here we know that our x is 18, so it's 18 squared plus minus 14 squared. Remember, when you're doing this, use a bracket, because if you don't, your calculator isn't going to understand that it's minus 14 times minus 14. It's going to think that it's 14 times 14 and then make it negative. And then we've got our 3 squared on the end. And then it is just a case of putting that into a calculator, and when we do that, we get the answer of 23. So for this, 2 marks. One for starting our process, so knowing that we've got to do the 18 squared plus the negative 14 squared plus the 3 squared. And then our second mark for that question is for the 23. So that's quite nice, easing us into this paper 2 for this paper, for this year even. So let's keep going on to question 2. Okay, so for question 2, we have a necklace is valued at £1,200. Its value is expected to increase by 4.5% per year over the next 3 years. Calculate the expected value of the necklace after this time, giving your answer to the nearest pound. So in here, we've got a few things that are important. So just kind of doing it there. So we've got 4.5% per year, 3 years, and nearest pound. Those are our most kind of important things we need to know. So first things first, our 4.5% per year. So that means we're starting with our 100%, and then we're adding on another 4.5%. So that gives us 104.5%. We need to change that into a decimal, and we do that by dividing by 100, so we get 1.045. So that's our decimal multiplier that we need for this question. So when we are doing that, after 3 years is what we're looking for. So after 3 years, what we're going to have is 1.045 to the power of 3. So our power is how many years we're doing it for. And then we're going to multiply it by the number that we started with, which in this case is 1,200. When we're doing this, we need to be careful and make sure that we're writing out our full answers before we write out our rounded answers, just in case. So we do 1.045 to the power of 3 times by 1,200, and we get 1369.39935. So equals to the nearest pound, that is 1,369. Right, so where do the marks come for this question? Your first mark for here is for having the 1.045 and knowing you have to multiply by it. Second one is for the line here, so knowing you've got to do it to the power of 3 and times it by the 1,200. And then final mark for this one is for getting your answer to the nearest pound. Like I said though, you need to be careful in that you need to make sure that you put your unrounded answers first, just in case. As with certain questions, they do require you to have the unrounded and rounded answers to get the marks. Here we go with question 3. So we have a piece of land is in the shape of a triangle as shown. So we know that P to Q, this side here, is 250 meters. We know that P to R is 180 meters. And it's telling us that the angle in here, QPR, is 147 degrees. The owner wishes to build a fence along our third side, so we need to calculate the length of the fence. In this case, we have 2 sides and an angle, and we're trying to find our third side. So that tells us that is going to be the cosine rule. Cosine rule as given, we get a squared is equal to b squared plus c squared minus 2 bc cos a. So in our triangle we have P, Q, and R. I don't want P, Q, and R. We can just change those. Our angle that we have is A, and our opposite one is A. B, doesn't matter which one we go, B there, and we can put B over here. That one's C, and we have C over there. So we can now substitute in our values. So we know B, which is 180, so we get 180 squared, plus C, which is 250, so 250 squared. Take away 2 lots of B, which was 180, C, which was 250, and then cos of 147 degrees. So this gives us our value for A squared. When we put that into our calculator, we have 180 squared plus 250 squared minus 2 times 180 times 250 times the cos of 147. We get the A squared is 170,380.3511. So A is the square root of that. So just copy it out again. When we're putting this in our calculator, we should just put square root answer, and we get 412.7715 and some extras. So rounding, so 412.77 or 0.8. As long as we round correctly, it doesn't matter really how we round. So we get our answer for A of 412.77 meters. So where do our marks come from in this question? First, we have our mark for substituting into our cosine formula correctly. So the 180 plus 250, that line there. Second mark is for getting our answer for A squared. And our second one is for our final answer. We should perhaps with this one, so it was asking quickly to find the side QR. So we should probably, at the bottom here, by our answer, write QR, which is equal to the 412.77 meters. That's it for question 3 and the cosine rule question. Let's keep going. Okay, so question 4. It says to solve the equation 2x squared plus 5x minus 4 equals 0, giving our answers correct to 1 decimal place. So this sentence here, correct to 1 decimal place when we have a quadratic equation, gives us the clue that we're not likely to be able to factorize this. So that means we are going to be using our quadratic formula. So the quadratic formula, which is on the formula sheet, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So from here we have, so normally it's in the form ax squared plus bx plus c equals 0. So there we can see that a is 2, b is 5, and c is negative 4. So now we can put our numbers in. So negative b, so we end up with negative 5, plus or minus the square root of 5 squared, minus 4, times 2, times, careful, negative 4, all divided by 2a, so 2 times 2. So let's sort out our bit under our square root, which is also called our discriminant, if we remember correctly. So if we put into our calculator 5 squared, take away 4 times 2 times negative 4, it's going to tell us that in there we've got 57, which is fine, and then on the bottom we have 4. So now, once we've simplified to this point, we can split into our two answers. So we get one answer where x is negative 5 plus my square root of 57, over 4. And we get another one where it's x is negative 5. Take away my square root of 57 over 4. Giving me two different answers. Remembering here, so again it says 1 decimal place. So we should be putting our unrounded answer first. So negative 5 plus the square root of 57 over 4 gives me 0.6374 and some extra. So that rounds to 0.6 when we're doing it to 1 decimal place. Our other one, we go back and we change, and it's the negative in there. So we get for that one negative 3.1374 and some more. So we round again, negative 3.1. So we get our two answers, x is 0.6 and x is negative 3.1. Remembering, of course, like I said, always put your unrounded answer before your rounded one. So in here, where do you get your marks? First one is for substituting correctly into your quadratic formula there. Our second mark is for our 57. And our third mark is for our final answers. And that is us for this question. Okay, so question 5. We have a theatre group which sold 4,830 tickets for their show. It was 15% more than they sold last year. How many tickets did they sell last year? So if they sold 15% more than last year, we're trying to get back to last year. So this is a reverse percentage question. One of the things, if you're unsure of what's going on, is check the number of marks. For 3 marks, it's going to be more complicated than just finding 15% and taking it away. So we're aiming for 100% as our final answer because that's last year. So we need to start with this year's, and it's 15% more. So that tells us our 115%. And that's what the 4,830 is equal to. It's not equal to 100%, it's equal to 115. And we're working back to 100. In this case, we can go to 1 in between. It's always safe to kind of go to 1% when we're doing these. So we're going to divide by 115 and then times by 100 to get back up to 100. And whatever I do to one side, I just do exactly the same to the other. So 4,830 divided by 115 gives me 42. And then I times that by 100 and I get 4,200, and I can just make a little comment just to be safe. So therefore, this is the math thing for therefore, it's like 3 dots. They sold 4,200 tickets last year. So where do our marks come from for this question? Let's have a look. So as we're going through the question, the first mark is for recognizing that it is 115% that is equal to 4,830. Seeing that it's not 100% that's equal to 4,830, but it is 115. Our second mark is for beginning a valid strategy, whatever that may be. So here, the fact that I've divided by 115 to get my 42. And then my final answer is for forgetting that they sold 4,200 tickets. Here we go with question 6. So we have a spherical sweet is made by coating caramel sphere evenly with chocolate. So we have the cross section shown there. So we have the outside diameter of 24, which is what it's saying here. So the diameter of the sweet is 24 millimeters, and the thickness of the chocolate coating is 3. We need to calculate the volume of the chocolate coating. So in this case, we need to calculate the volume of the whole sweet. We then need to calculate the volume of the caramel. And then we're going to have to find the volume of the chocolate, which is going to be the volume of the sweet take away the volume of the caramel. So we're finding the whole thing, taking away the caramel. We've got spheres. So for sphere it is 4/3 pi r cubed for our formulas. That is on the formula sheet, so no excuses in getting that one wrong. So it's 4/3 times the whole suite has a diameter of 24, so that means it has a radius of 12. So we do 4/3 times pi times 12 cubes. 12 cubed even, not 12 cubes, that doesn't make any sense. 12 cubed, not squared. Wrong button on my calculator there. That's fine though. So we get 7,238.229474. It will keep going though. So the volume of the caramel, so we have 4/3 times pi times, and then our radius here is what we need to work out. So kind of visually, if we draw in our diameter at some point, so I'm just going to draw in here, that's our radius there. So we know the whole thing we worked out is 12. That bit is 3, so that tells us our caramel has a radius of 9 millimeters. When we're doing this as well, we should always put units on. I forgot about that one there, so millimeters cubed. So then this one is times by 9 cubed. So 4/3 times pi times 9 cubed gives us an answer of 3,053.628 and some extra. So the volume of the chocolate is going to be 7,238.2. I'm just going to round to one decimal place here. So I'll go back and round in here. So 7,238.2 for that one. Millimeters cubed. I even said I needed units and then didn't put them on the second one. Second one, if we do this, we get 3,053.6 millimeters cubed when we round to one decimal place. So take that away, and we get our answer. So 7,238.2, take away our 3,053.6, and we get 4,184.6 millimeters cubed. And then just realised I hadn't finished reading the question, so this is really careful here. Give your answer correct to 3 significant figures. So this is where it's always worth looking back at the question, check you've actually answered what it says. So there, 3 significant figures. So that means that's our first significant figure, that's our second one, that's our third one. So it's saying round it to the nearest 10. So we get 4,180 in this case because the 4 after. And it's going to be millimeters cubed as our final answer. So where do our marks come? In this question it's worth quite a lot of marks, at 5 here. So our first mark is knowing that we need to find the difference between the two volumes. So showing evidence that you needed to do a takeaway somewhere in there. Our first mark is, second mark even, is for knowing that you've got to do 4/3 times pi times 12 cubed and kind of getting your answer there. Our third mark is for our answer for the caramel, so 4/3 times pi times 9 cubed, and getting your answer there. Fourth mark is for kind of an unrounded version, and then our final fifth mark is for our 3 significant figures. In this question, I think this is a case where if you didn't have your units, you weren't getting all your marks, so you need to just be careful. Make sure you put units where you can. Right. So we have here question 7. Triangles A and B are shown below. So we have triangle A where we've got sides 6, 7 and 8. And we have triangle B where we've got sides 6, 7 and 19. It's asking us, so the triangles are placed together to form a larger triangle. Is this triangle right-angled or not? So we put some kind of information in. So this side we know is 8 centimeters. This one we know is 19 centimeters. And then our bottom of it is going to be our 6 and our 16. So altogether that is going to give us 22 centimeters there. So we've got our three sides and we're asking, is this got a right angle? This means we're trying to work out converse of Pythagoras. So when we're doing this, we need to remember and be careful, we do not set them equal to start with because we don't know if they're going to be. So we work out c squared, which in this case it's always your biggest number squared. So in this case that's 22. So we get 22 squared, which is 484. Then if we work out a squared plus b squared, so that's going to be 8 squared plus 19 squared. So that gives us 8 squared plus 19 squared, which is 425. So as we can see, they are not equal. So we can make a comment now. So as c squared does not equal a squared plus b squared, as 484 does not equal 425. By the converse of Pythagoras, you need to state that you're using the converse of Pythagoras. So by the converse of Pythagoras, this triangle does not have a right angle. Or does not contain a right angle. Okay, so where are we going with this one? Our converse of Pythagoras questions, you need to be super careful with how you word them and what you're doing. So when we're doing our first step, as I said already, you cannot say that, you cannot start by putting, I'm just going to put in red here, we cannot have this written. That means if you put your working in like that, you're not going to get your marks. You need to expressly show the fact that you understand that they aren't equal and you're trying to prove that they are, or prove that they are not. So in this one, so your first marks is for both of these steps here. So for doing 22 squared and for doing 8 squared plus 19 squared. Your second mark is for working out what both of those, so your answers to those. And then your third mark is for your comparison and conclusion, using the fact that you're saying that it's the converse of Pythagoras. Here we go with question 8. So we have in the diagram below, we have R to Q and P to Q represented by vectors C and D. So P to Q is D and R to Q is C. So for part A, it's asking us to express PR in terms of C and D. So how do we get from here to here? So when we're doing vector pathways, we're looking for an alternate route. So our shortest route would obviously be good to go this way. However, we can't, because we don't have the information to be able to do that. So we're going to have to go the long way around. So we're going to have to go from P to Q and then from Q to R. So PR, just writing down kind of what I'm doing. So I'm going to go from P to Q, and then I'm going to go from Q to R. So looking from P to Q, I'm going with the flow of my arrow, so it's plus, which is fine. So that is D. But then for Q to R, I'm going against the flow of the arrow, so that means I'm doing the negative of the vector. So in that case, I'm doing take away C. Right. So for part B, it is said now, so the line QP is extended to T, and it's saying that T to P is the same as P to Q. So the other thing, so what that is telling us is that is the same as vector D in there. And it's told us that V is halfway along that point there, so we have to figure out how we're going to get from here at T to V using just the things we have. So here we're going to have to, again, we're going the long way. So we're going to go from here to here. and then we can go from there across to here. So we know how to get from P to R, and because it says it's the midpoint, that means the middle, so halfway along. So we're going to have half of this. So from T to V, we're going to go from T to P, and we're going to then do half of P to R. And I wrote Q, not R, but it is R. We've got that going to Q wouldn't help us out in this situation. So from T to P we know is D, and we know P to R because we worked that out in part A, and it is D take away C. So sorting that out, so we have D there plus a half D, multiplying this out, take away a half C. So simplifying that, or kind of sorting it out together, I would keep going down again, but I've run out of space. Should have done it over at the side. So we end up with D plus a half D, so that's 3 halves of D, or 1.5 D. Take away a half of C. So what are my marks here for this question? We have our first one, obviously it's out of 1. So that is our only possible mark, D take away C, or something equivalent. So you could do negative C plus D is fine. Second one, first mark, is for knowing a valid kind of root. So what I've written there, so that T to V is T to P plus a half P to R. And then getting our final answer of 3 over 2 D take away a half C. That gives us our second mark for part B. Here we are with question 9. So part A and part B, they're going to go together. But start us off, so we have for A, we have to factorize 4x squared, take away 25. So looking at this, we have, when we factorize, we've got 3 options. We have a common factor, we have a difference of 2 squares, or we have a trinomial. So common factor, 4 and 25, nothing, x squared and nothing, so there's no common factor there. Difference of 2 squares. Can I write 4 as something squared? Yes, I can. It's 2 squared. X squared, it's already in there. 25, that's a square too. 5 squared, and difference means subtract. So that's what we have. So I can write this as kind of 2x squared take away 5 squared. So I've written it as my squares. And then when we've got our squares, we get the 2x and the 5 in one bracket, and we get the 2x and the 5 in the other, and we have one with a plus and one with a minus. Factorized part A, and then B it says hence simplify. So that gives us the top of our fraction. I'm going to write it out as was first. So we have 4x squared minus 25 over 2x squared minus x minus 10. And so we know the top gives us 2x plus 5, and then 2x minus 5. So the bottom, we need to figure out what we're factorizing to, so it's going to be 2 brackets. Looking at this first one, so our 2x squared comes from the first 2 terms in here. So 2x squared, my only 2 factors of 2x squared are 2x and x. So that's what's going to have to go in the front of my 2 brackets. Then looking at my 10, I've got a few options. I've got 5 and 2, or I've got 1 and 10. It said we can simplify though, so we can take a hint in that our 2 brackets at the top have 5s in there. So we know that it's going to be the 5 and the 2. The situation is which way round they go. The other thing is we know that it's going to have to be 2x and 5 in the same bracket. So that gives us our hint that there's going to have to be a 5 in there and a 2 there. And then our option is whether or not it's a plus or a minus. So if we look at our middle term is negative x. So that tells us our larger term when we multiply out is going to have to be negative. So looking at this, we multiply our first one and our last one together, and we get 4x. We multiply our 5 and our x together, and we get 5x. So here, because this is negative, our bigger one, so the 5x is going to have to be negative. So that came from multiplying here. So our negative is going to have to go in there, and our positive is going to have to go there. Now, because we've got two things at the same top and bottom, we can cancel them out, leaving us with just the 2x plus 5 on the top and the x plus 2 on the bottom. So when you're doing this question, or a question similar to this one obviously, be careful and look for the hints of you're going to have a matching bracket top and bottom to see what's going on. So that gave us the clue when we were factoring as the bottom that we're going to have to have 2x and 5 in one of the brackets. It could have been a plus or a minus, but either way, and then you work out from there which one it is you actually want. So for this, our marks, part A obviously is just our 1 mark in there. For part B, we get 1 mark for starting to factorize on the bottom. So what I mean by that is if we've got 2x and 5 and x and 2, that's where the mark comes from, like the first one, like without having the signs the right way around. Completing the factorizing, so putting the signs in the right way, the negative and the plus round the correct way, gets you mark number 2. And then simplifying to get rid of our 2 brackets that are the same gets us mark number 3. Question 10 now. So we have bearings, which is everyone's favourite, just after quadratics, I think, right? So in our diagram below we have D, E and F representing the positions of Dunbridge, Earlsford and Fairtown respectively. It tells us that Dunbridge is 15 kilometres east of Earlsford, so Dunbridge is 15 kilometres to the east, kilometres west even, sorry, of Earlsford, so that gives us some information there. So that tells us that's west and east-west line there. From Dunbridge, so from here, the bearing down to there is 126, which we've got marked on. And we've got from Earlsford, our bearing round that way is 230. And we need to calculate the distance between Dunbridge and Fairtown. So we need to calculate this side here. So I'm just going to put a big question mark as to show us kind of that's what we're trying to aim for. So we have a triangle, we've got lots of angles in there, we've got 2 sides, so this should kind of give us a clue that eventually we're ending for the sine rule. So we've got a triangle, there's no right angles, and we're not being asked about all 3 things, so sine rule is where we're going to go eventually. So, but first we need to kind of figure out some stuff in here. So the fact that it said west, that gives us some clues. So that gives us the fact that we've got 90 degrees in there, and I've got 90 degrees in there, because east and west are 90 degrees. So that gives us somewhere to start as well. So there we know here at D for Dunbridge, we know we've got 126 all the way round to here, and 90 in there. That tells us that in here we have to have 36 degrees. And then other side, we know that this is 230 and this is 90. We know that round a point has to add up to 360 degrees, 1 full turn, 360. So we've got the 230 plus another 90, so that gives us 320. So in here is going to have to be 40 degrees. So we're getting there. We've got quite a lot of things within our triangle. We might as well work out our third angle because we're going to need it actually. Reason why we're going to need that angle is because we have 15 kilometers. So with the sine rule we need the side that's opposite. So we need this one in here. So we've got our 36 and our 40. And we know that our angles in a triangle have to add up to 360. So if we do our 180, take away 40 and 36, we get that in here is 104 degrees. And then we have enough to do our sine rule. So sine rule, we have A over sine A is equal to b over sine b is equal to c over sine c. In this case we don't have ABC, so we can make it ABC. A, B, C. So A is over here, B is over there, which is what we're looking for, and C is up there. So if we tick kind of what we've been given in the question, so we know the size of angle A, angle B, and angle C. We know the size of side C, and we're trying to find side B. So those are the two that we're going to want. We don't need anything to do with A. So we're going to get B over sine B is equal to C over sine C. Substituting in our numbers, so B we don't know. Over the sine of B, which was 40, is equal to C, which was 15, over the sine of C, which will be sine 104. Now we've got B divided by sine 40, so to get rid of that to the other side we need to multiply. So we get B is 15 over sine 104 times by sine 40. We also know that B is the same as the distance between Dunbridge and Fairtown. There, again, I would go down, but I've run out of space. So we get 15 over sine 104, making sure we're going outside of our brackets, so then do times by sine 40. We can also put the sine 40 on the top of the bracket if we wish, which gives us an answer of 9.9369 and some more. So I'm just going to write a sentence. So the distance is 9.94 kilometers for my answer. So let's see where the marks come for this question. So our first mark here is for calculating the sizes of these angles in there, so the 104 and the 40. Our second mark is for correct substitution into our sine rule, so down here. Rearranging the formula to this one gets our third mark, and then our final mark is for our answer. With this question, one of the most kind of difficult bits can be to recognise that it is the sine rule. In this case, looking for triangles, there's no right angles, so it's either the sine rule or the cosine rule, and we didn't have enough information about the sides for it to be the cosine rule, so that's how we knew it had to be the sine rule. That's it for question 10. Let's get on to question 11. Okay, so we have here question 11. The straight line has equation 3x minus 5y minus 10 equals 0. Find the gradient of the straight line. A lot of times when people see this question, they don't understand. What this is actually asking is rearrange the formula, change the subject to y. So here it is saying change the subject and then tell me what m is. So first of all, we've got 3x minus 5y minus 10 equals 0. We're looking for y equals. So on this side we've got this minus 5y, so we want to move that around. So in this case it's easiest just add 5y to both sides. So I add 5y to this side and I add 5y to that side. So I get 3x take away 10 is equal to 5y. I can write this round the other way because people like it that way. 5y equals 3x take away 10. There, now I need to divide both sides by 5 because I don't want 5y equals x plus 3, I want y, and I'm dividing each term by 5. So 5y divided by 5 just gives me y. 3x divided by 5 gives me 3/5 of x, and 10 divided by 5 gives me 2. So now it looks like my formula y equals mx plus c. And here we have the information, so whatever number is in front of my x when it's in this form is my gradient. So I can say the gradient equals 3/5. What are my marks for this question? First mark here is for starting to sort something out, so getting the 5y by itself, so isolating your y term on its own. And then we get our second mark for stating explicitly that it's the gradient is equal to 3/5. It can't be part of the equation, you need to actually state it separately. And that's it for question 11. So we'll keep going and we'll get to question 12. Right, so question 12, we have to express 1 over the cube root of x in the form x to the n. So we've got multiple things here. First things first is that this is written as a number over a third. We need to change our third into a fractional power. When we're doing that, if we've got any thing under a root, so I'm just going to call it like an nth root of something, that can change into, our index rule tells us that our root goes on the bottom, our power goes on the top, so we can rewrite this, any root at all, we take it and we rewrite it, so whatever number is in our power position goes to the top of the fraction, and whatever number is in the root goes on the bottom. So with this one, because we have 1 over the cube root of x, we have 1 over, it's going to be x to a fractional power, and in here our power there, when there's no power written, then it's 1, so on the top of my fraction goes a 1, and then on the bottom of my fraction goes my root number, so that's a 3, so we get there, so we get 1 over x to the power of a third, and then we need to write it as a positive index when we take things from being either on the bottom of a fraction, so when we're swapping things from being numerator to denominator, we swap from positive to negative, so we end up with x is negative, x to the power of negative 1/3. So in this case your first mark is for 1 over x to the third, second mark for x to the negative 1/3. So pretty straightforward for that one as long as we remember our index rules. Here we go, question 13. So we have 2 identical shapes are used to form a logo. Each shape is part of the circle, and we have the circles have centers C1 and C2. We know the radius is 14. The logo has half-turn symmetry about the middle, and the AB is 48 centimeters long. So we now have to calculate the total height of our logo. So here we've got a lot of circles, but realistically what we're doing here is trying to make triangles. So here we're looking for this distance there, x. We know that this here is our radius. We know that this triangle, because it's identical, that's our x as well, not an r. That's an x. And because of the fact that we've got kind of things in there, we're going to have lots of isosceles triangles. So we can make right-angled triangles. So our triangle, kind of, if I draw it out separate, the other thing we know about that triangle there is that this is our radius too, because it's going from the middle to the edge. So lots of radiuses about there. The other thing we can see is that it's told us from A to B is 48. And so we've actually got 1, 2, 3, 4 identical triangles that make up that 48. So that's telling me that the bottom has got to be 12. It told me that the radius was 14. So that's the side I need to find here. So it's Pythagoras question. Looking for triangles inside our circles. So here we're finding a shorter side with Pythagoras. So that means we're going to have to use a squared equals c squared minus b squared. So we get 14 squared, take away 12 squared, which is going to give us 52. So we get a squared is 52, so a is the square root of 52, which is 7.211 and some extra, So say 7.2 centimeters. So now the height is going to be equal to 2 times my radius, because I've got another radius in there. So it's a radius and an x and a radius. I know over there x has become a, but that's okay. Plus 2 times my 7.2. So altogether, 2 times 14 plus 2 times 7.2 gives me 42.4 centimeters as my answers for question 13. So let's check where our marks are for this. So for the first one is for kind of sorting out your facts and recognizing that you have the right angle triangle with 14 and 12. Second mark is for knowing that that side there is 14 squared, take away 12 squared. Third mark is for getting that that bit is 7.2, and our final mark is for getting our height as 42.4 centimeters. So there, the hardest part is recognizing that it's looking for triangles, especially considering there's no triangles there to start with, there's just a whole load of circles. But hopefully we should be doing enough past papers to see that we're looking for triangles inside our circles so that we're able to do Pythagoras. Let's get going then with the next question, question 14. Here we go. So we have a diagram shows part of a circle with a centre 0. We know that the radius of the circle is 6.4 centimeters, and we know that the arc length AB, so that's saying it says the major arc length as well, so that's telling us a long way around, this way around. Not a very good circle, but that's okay. It's 31.5 centimeters. And it's asking us how big is my reflex angle in the middle. So when we're doing arcs and sectors, we know that our angle divided by 360, so the reason why this is the case is because our angle is part of the circle and our 360 is the whole of the circle. And then the other thing we know is the major arc, so that's part of our circle, and because it's an arc, it's the distance around the edge. So part of the distance around the circle is 31.5, and so in this case, yep, we have arc, and with arc comes circumference. So our arc is part of the circumference, just like our angle is part of the full circle. We also have that a sector is part of the full area. So in this case we can start putting in our numbers. So x kind of is what we're looking for. We have 360 degrees that we know about. Our arc we know is 31.5. And we know the circumference of a circle is pi d. We know our radius is 6.4. So our diameter is going to be double that, which is 12.8. So we get pi times 12.8 there for our circumference. So we can say x is equal to, we've got divide by 360 here. So similar to our sine rule, when we have a fraction equal to another fraction, we can get rid of this bit on the bottom by multiplying the other side by it. So we get 31.5 over pi times 12.8 times by 360 degrees. So when we put that in, we have 31.5 over pi times 12.8. Remember to go outside of our fraction to put our times by 360. And we get x 282.002. So 282.0 degrees. Here, 3 marks. So the method I've used, our first mark, is for knowing that we have to kind of equate there of the 31.5 over pi times 12.8. Second mark for times by 360. And our third mark for getting our answer. So we've almost reached the end of this paper, so we're getting into the really A questions here, the difficult ones. So we've got a wind turbine with 3 blades shown below. The height h in meters of the tip of the blade is shown in each rotation by h equals 40 plus 23 cos x. And it's telling us that x can be equal to 0 or greater than 0, but not more than 360. And it said x is the angle blade A has turned clockwise from its vertical position. It's got a little diagram showing us that. So we need to calculate the height of the tip of blade A after it has turned through an angle of 60 degrees. So for part A, straightforward, it's just a case of it tells us x equals 60 degrees. So h is 40 plus 23 times cos of 60. So just putting that into our calculator, remembering we're in degrees. So 40 plus 23 times the cos of 60 gives us 51.5, and it says it's in meters, so that's our answer for part A. For part B, it's asking us to find the minimum height that the tip of the blade can be. So the minimum height is going to happen when we've gone through half a rotation. So that's going to be when cos is 180. So that's our main thing here, is understanding that x for that one is going to be 180 degrees. So we get height, which is going to be 40 plus 23 times the cos of 180 degrees, which gives us an answer of 40 plus 23 times cos 180, just saying it again as I put it into calculator so don't get it wrong. So we get 17 meters for part B. These two are just a mark for getting our answers. And we've still got one more part to this question. I think part C, there might be a part D as well, we'll see in a second. Okay, so we have a part C, like I said, there's no part D, but we do have a part C. So it says calculate the values for x for which the tip of blade A is 61 meters above the ground. So our formula was h is equal to 40 plus 23 cos x degrees. So it's telling us our height is 61, so that's giving us 61 equals 40 plus 23 cos x degrees. We need to rearrange this to get cos x equals, so I'll write it round the other way. So we have 60 plus 23 cos x degrees is equal to 61. So it's not 60 over here, I wrote 60, it's not, it's 40. Okay, so then here, doing same as if we were solving any basic equation, we have 40 on both sides that we don't want, so we're going to take that 40 away. So we get 23 cos x is equal to 21. And then we're going to divide both sides by 23 because we don't want our 23 there. So we're going to get cos x degrees is equal to 21 over 23. Don't know why I put it in a bracket there, but I did. So thinking about our cos graph now. So our cos graph starts, goes down, back up to there. So that's our 90, that's 180, that's 270, and then we've got our final bit at 360. And that's our 0. We've got 21 over 23, and it's positive as well. So that's telling us we're going to have two answers. One slightly more than 270 and one slightly less than 90. So to do this we need to first of all find our acute angle, and we're doing this by finding the inverse cos of 21 over 23. When we do that, inverse cos 21 over 23, again, sorry for just saying these things out again, it's because I'm using my calculator to like I'm saying it as I type it into my calculator, so don't do anything wrong. So I get 24.07 degrees. As you can see, my drawing, not so great. Really 21 over 23 should be closer, but we know it's between 0 and 90, and 24.07 is. There's other bits after that, but that's not a problem. So we get, though, so we have two values for x. So we've got our first one, which is between 0 and 90, which we know, which is 24.07 degrees. And then we've got our second answer, where we are starting, so we start at 360 and we go backwards. Because of the symmetry of our graph, whatever we go forward from 0, it's the same as going backwards from 360. So our second one is going to be 360 degrees. Take away my 24.07. So then I have my two answers, 24.07 degrees, and my second answer, which is 335.93 degrees. So looking at those, where do our marks come for this question? So first mark is for knowing to set it equal to 61. So just that bit there, even if you can't keep going further than that, enough to get your first mark in there. Right, so second mark is for rearranging to get to cos x equals 21 over 23. Our second mark is for finding our value of x of 24.07, and then our fourth mark is for our second answer of 335.93. So that is the end of this 2017 calculator paper. Hopefully going through that has been helpful for you. Like I said at the start, if you've made it this far, well done, and hopefully there's something in there that's been able to help you. If you've got any comments or questions, please feel free to leave a comment, and hopefully the rest of this playlist is useful for you as well, because I've got previous past papers, and I'm sure by the time someone actually listens to this, I'll have the next one uploaded too. So thank you very much for watching, and I hope that's been helpful for you, and good luck for your exam whenever that may be.